As you've probably been told, light and sound are both waves. Light waves can be spread out like a light bulb or focused like a laser. But can you do the same for sound? Surprisingly, the answer is yes. And I'm going to show you how I built this device, and how you could build your own. So normally when sound travels, it disperses and spreads out like you'd expect. But this is actually dependent on the frequency. The higher the frequency, the more focused the beam is. I don't know why the math works out this way, but I just accept it. But the big issue is that the frequencies needed to get sound focused are actually in the ultrasound range, so it's beyond the range of human hearing. But there's this really weird physics glitch. Okay, it's not a glitch, but it's a weird property where when the frequency and amplitude are high enough, the air itself becomes a nonlinear medium and is able to demodulate a modulated waveform. Yeah, it doesn't really make sense to me either, but I'll link the Wikipedia article. But anyway, that aside, it means we can encode audible sounds by modulating them with an ultrasound carrier wave. This is actually exactly the same as how FM radio works, only the ultrasound frequencies are in the kilohertz instead of megahertz. And since individual ultrasonic speakers are pretty small and not very loud, I actually have a bunch of them connected in parallel. Designing a circuit for this was pretty straightforward. The audio comes in here with a simple high-pass filter to get rid of DC offset. That signal travels to a standard 555 timer to modulate a 40 kHz square wave. Finally, it's fed into an amplifier to drive the speaker array. It's powered by a 12-volt power supply for the speakers with a 5-volt regulator for the logic parts. So how well does it work? Really well. It's so hard to show in a video though, you really have to be there to experience it. But I can at least describe what it's like. First thing to notice is that the sound travels pretty straight through the air, but as soon as it hits a surface, it demodulates and becomes audible. So if I point it at a wall, it really sounds like the sound is coming from the wall, not from the speaker. And as I rotate it, it sounds like the sound is crawling along the wall to the ceiling. If I point it at someone's head, they can tell it's coming from the speaker, but to another observer, it sounds like it's coming from that person. Pretty cool. But that means if you're trying to make only one person hear it, it has to be pretty quiet to eliminate reflected sound. Another interesting thing compared to normal speakers is that very small objects can completely block the sound. Just putting a piece of paper in front blocks it completely.
The obvious two techniques to use here are combinations and LSTMs, since we're dealing with spatial produce bad results, and I'll explain why.
Anyway, hope you learned something new. It was a really fun project to put together, and I'd encourage anyone who wants to make something similar to give it a shot. Minus some tuning, it wasn't as difficult as I thought it would be. Thanks for watching.